So here we go. We'll try again. I recorded this lesson already, but it didn't record any sound. So make sure the absolute value. We're going to solve absolute value equations, and then we maybe do one other unit. I wasn't for sure exactly where we needed to stop in this unit, so I ended up copying off way more than we needed. We'll definitely touch absolute values, and then one other section, and I think we may call it good for this chapter and move on to something else. So there's extra stuff there. Anyway, when we solve an absolute value, so an absolute value question is going to be, what we have to know is absolute value is the distance from 0. That's what an absolute value is. So that's why the absolute value of -4 is equal to 4. Because -4 is 4 units to the left of 0. And because the absolute value is a distance, therefore it always has to be positive. Okay? And therefore when I take the absolute value of 4 is 4 because it is 4 units from 0. So that's what we have to understand what an absolute value is in order to solve the absolute value problem. So we have some steps here to solve this absolute value expression, absolute value equation. We have to make sure the absolute value expression is isolated. We have to get it by itself. That hasn't happened until page 2 in our notes, but we're going to set the inside equal to both the positive and the negative number. See, we can see that we could be 4 units to the left, we could be 4 units to the right. Okay, so that's why we're going to do the positive and negative. We're going to solve both equations, and then we're going to write this as a solution set. Now, I'm not going to get too worried that you write your answer in set notation or anything like that. It's just that's what this particular author wanted to set equal to. Okay, so away we go. So in problem number 1 here, we are trying to find a number for x where the distance from 0 is 2. Well, I happen to know that 2 is 2 units from 0, and so is -2. It is also 2 units from 0. And that's all there is to it, because there was nothing inside the absolute value to work with. The same thing is going to happen on number 2. I know that 14 is 14 units from 0. I also know that -14 is 14 units from 0. Moving on. Now in 3, here we start to actually get to some operations. My absolute value is isolated, so we're going to have 5z. It could be 40, but I also know that -40 is also 40 units away, so we're going to set that equal to a -40 as well. So when I divide by 5, it turns out that z is equal to 8. And over here, when I divide by 5, z is equal to a -8. Okay. All right. And then this process continues. -7a is going to equal 28. -7a could also be -28 because it's going to go 28 units left of 0. All right. So we're going to divide out this -7. And that's going to give me a -4. We're going to divide out the -7. And a is going to equal +4. And we have those solved. Again, these are fairly simple ones. All we have to remember is the number and its opposite. So I know something is going to equal 8. And I know -8 is also 8 units from 0. So that means that d plus 1 is going to equal 8. And d plus 1 is going to be -8. So we're going to subtract 1 and get d is equal to 7. We're going to subtract 1 and find out that d is equal to a -9. This one, again, the first one reads just like it sits. W minus 3 can equal 4. However, -4 is also 4 units from 0. So we're going to set that equal to -4 as well. We're going to add the 3 and find out that w is equal to 7. We're going to add the 3 and find out that w is equal to a -1. Okay. Again, then these all work the same. It's just we're going to make the solving it more complex. 4n plus 2 is going to equal 34. And 4n plus 2 can also equal a negative 34. So we're going to subtract the 2 over to get 4n is equal to 32. We're going to divide that 4 out of there and find out that n is equal to 8. I guess that's an equal sign. I couldn't tell what that was. We're going to subtract the 2. Again, since we're doing it this way, all my steps are the same. We're going to subtract 2 and then divide by 4 and get negative 9. Negative 2v minus 5 is equal to 17. Negative 2v minus 5 is equal to a negative 17. So we're going to add that 5 over. We're going to add the 5 over. Negative 2v is equal to 22. Divide out the negative 2. And v is going to be a negative 11. Add 5 and add 5. Negative 2v is going to give me a negative 12. We're going to divide out that negative 2. And v is equal to a 6. Okay, that first page is done. So we got about 10 more problems to go. I don't know. The back side. So that was solving one type of equation. All these equations, the absolute value was already isolated. There wasn't anything special that we needed to do beforehand in order to solve that. Now what's going to happen is, what if there is stuff outside the absolute value bars, okay? And we're going to isolate the absolute value. Okay, so in this case, my absolute value is going to be C. Here, actually, let's undo that. So here's my absolute value. I need to isolate it. So I'm going to get that yellow mark all by itself. So we need to subtract the 2 over first. So now we're left with the absolute value of C is equal to 10. And now we have exactly what we had on the front side. I needed some number that's 10 units away from 0. Well, I know that 10 is 10 units from 0. And I also know that negative 10 is also going to be 10 units from 0. Okay? Same thing happens here first. There's my absolute value. We need to isolate it first. Get the yellow mark by itself. So we're going to add 8 and add 8. So we have the absolute value of y is going to equal 3. So I know y is equal to 3 and y is equal to negative 3. Again, it's pretty much the same process. I've got this, the absolute value. I have to get all by itself. We need to get rid of that 6. So we're going to divide out the 6. We're going to get the absolute value of x is equal to 4. So now I can say that x is equal to 4 and x is equal to negative 4. The absolute value is going to be z plus 3. So we have to isolate that first. So we're going to divide out the negative 2, divide out the negative 2. So now we have z plus 3 is equal to 7. So now we have 2 to solve. Z plus 3 is going to equal 7. Z plus 3 is going to equal a negative 7. So we're going to subtract the 3 out of there to get z is equal to 4. We're going to subtract the 3 out of there to get z is equal to a negative 10. All right, and again, this process is going to remain the same all the way through. We have to isolate what I highlighted, the absolute value. So that means we have to get rid of the 6. So we're going to multiply by 6, and we're going to multiply by 6. So I'm left with that 2w minus 4 is equal to 18. And now since it's isolated, there's nothing else around it, we can set up my 2. 2w minus 4 is equal to 18. 2w minus 4 is equal to a negative 18. So we're going to add the 4 out of there to get 2w is equal to 22. Divide out the 2, and so we get w is equal to 11. Again, my processes are going to be the same. We're going to add the 4 out of there. We're going to get 2w is equal to negative 14. We're going to divide the 2 out and divide the 2 out. We're going to find out that w is equal to negative 7. Okay. Now, 14 is a little bit different in the fact that we have multiple operations to do. There's the h plus 5. That's the absolute value that we're trying to isolate. But I've got it multiplied by negative 10, and I've got a subtraction of 3 here. So we're going to undo that by adding the 3 over. So this one had 2 steps to do before we get there. Negative 10. We've got h plus 5. We added the 3 to cancel out, and so we get a negative 80. And now I'm going to divide out this negative 10. And so it took a little bit longer, but we have arrived at my isolated absolute value. H plus 5 is equal to 8. So h plus 5 is equal to 8, and h plus 5 could be negative 8, 8 units to the left. All that remains the same. So we're going to subtract the 5 to get h is equal to 3. I'm going to subtract the 5 to get h is equal to a negative 13. Second verse, same as the first. Continues to do the same things here. So 4n plus 8 is my absolute value. Again, this works like a little bit like the last one did. We're going to add the 6 to get it out of there. So we have 7 times the absolute value of 4n plus 8 equals 112. We're going to divide the 7 out of there. And so that means that the absolute value of 4n plus 8 is going to equal to, what is that, 16, I believe. And now we're ready to solve that. 4n plus 8 is equal to 16. 4n plus 8 is equal to a negative 16. And now, again, that process worked the same way. We just take whatever's in the absolute value. We could be 16 units to the right. We could be 16 units to the left. Okay? Anyway, we're going to subtract the 8. Find out that 4n is equal to 24. We're going to divide that 4 out of there and find out that n is equal to 6. Subtract the 8 out of there to find out that 4n is equal to a negative 24. See, I goofed up the other side. That's all right. I'll come back and fix it. So if you're going, whoa, Mr. Dottie, yeah, you're right. I'm getting in a hurry. That's a negative 6. So I got to come back to this one and grab my eraser tool because I got this wrong. 16 minus 8 is not 24. 16 minus 8 is 8. And so that means that my answer is not 6. Why did you disappear? Okay, there we go. All right, one more to go here. It gets a little bit convoluted and complicated. Again, we're trying to isolate the absolute value. We're going to add the 24 over. We're going to get 3 halves times the absolute value of 4r minus 4. I have to multiply by this reciprocal of 2/3. My 3's cancel, so I'm left with a 2. And I had to remember that was inside an absolute value. So that means I'm going to have 2 to solve. 4r minus 4 is equal to 2. 4r minus 4 could also be a negative 2. Add the 4 to get 6. We're going to have to divide the 4 out and find out that r is equal to 3 halves. We're going to add the 4 and add the 4. So 4r is equal to 2. We're going to divide the 4 out and find out that r is equal to 1/2. So again, it's the same exact stuff. That one's just a little bit more complicated because we have the fractional answers. All right, now there are some special cases. We have to remember that the absolute value is a distance. So it is always positive. So what happens here? I've got an absolute value equaling a -6. And what should happen is that should raise a red flag. Okay, because I'm trying to say the distance between 0 and 6, 0, and this number is going to be -6. Well, I can't do this. This is going to be a no solution problem because there's no way, and actually I guess this explanation should have gone here. Okay, or we'll just write this out. Since a distance cannot be negative, there is no solution when absolute value expression equals a negative number. Now, again, sometimes we do some things to get back to it. So let's come up here to 12, for example. In number 12, we've got this -14 over here. We got the absolute value expression equaling -14. But in this particular case, I had to divide across this -2 when those two negatives made a positive, and that's something that I could solve because my absolute value expression equaled a positive number. Okay, so it's not like we look at the original. Okay, so in this case, again, we have the absolute value equaling a negative number. We can't have that, so this is no solution. If I grab my pen, again, in order to solve this, I have to divide over the -3. So now we have the absolute value of 2x plus 1 equaling a -7. And again, whenever I get this distance equal to so I've got this absolute value distance equal to a negative number, that again is my red flag. And my answer is no solution. Alrighty, we've knocked that out. So we'll do this lecture and another lecture, and we'll call it good.